Welcome, my name is Peter Eckelmann. I'm Product Marketing Engineer at MSC Vertriebs GmbH. Today I would like to introduce a new type of ComExpress module with the AMD embedded R-Series. This new module is a ComExpress compact module, which means it has dimensions of 95 by 95 millimeters. ComExpress allows for 3 different sizes: ComExpress Compact, ComExpress Basic and ComExpress Extended. And this is the type Compact, which allows for very compact systems, hence the name Compact. It is also a new type of interface. It's type 6 rather than type 2. Previous modules were all ComExpress type 2, and now, since the extension of the ComExpress definition, the type 2 has been accompanied by type 6, which allows for newer interfaces to be implemented. However, it also requires a new type of baseboard to adapt these signal lines and make use of the new features like the high-speed display interfaces, HDMI, DisplayPort, and also USB 3 is now possible with type 6 interface standard. This module is called C6C-A7. A7 refers to the AMD Fusion controller hub used on the module, the A70M, and the CPU belongs to the embedded R-Series, and the whole module is called C6C-A7 because C6 is ComExpress type 6, the other C refers to the compact size, and the A7, of course, is a reference to the AMD controller hub. On this module, first of all, we've got the CPU, which can be a dual-core or a quad-core CPU, up to 2.1 GHz. And if not all cores are busy, then the turbo mode can bring up the speed up to 2.8 GHz in order to solve numerical issues as quickly as possible. Independent of this, the CPU is very power efficient, and as you can see here in our demo system, the CPU that only requires very little cooling, but still delivering very high graphics and computing performance at the same time. Next to the CPU and the controller hub, you can see a DRAM socket here on the module, and there is a second one on the other side. Both modules can accept DDR3 SODIMMs, DDR3-1600, very fast memory modules. And that means on the module we can have a dual channel memory channel, which allows for very fast memory transfer to the CPU and back from the CPU into the memory again. Both channels can operate independently at the same time, effectively doubling the memory bandwidth of one single memory. Now let's come back to the CPU, which integrates a graphics unit, which is very, very powerful and makes this module a real high performer when it comes to very fast 2D and 3D graphics. The CPU includes an integrated Radeon HD 7000 series graphics, which allows for features like DirectX 11 and OpenGL 4.2. These are graphics standards which are currently at the top end of what can be achieved with integrated graphics. And sometimes the integrated Radeon HD 7000 series graphics is also referred to as discrete graphics card performance, because a similar performance as that was formerly only available by using discrete external graphics cards on the CPU board. Now here we've got this graphics power integrated in the CPU, And the CPU, as I said, can be a dual-core or a quad-core CPU. It would be nice if it was possible to make use of the number crunching performance of the integrated graphics unit of the Radeon HD 7000 series graphics on the chip to solve high-performance number crunching issues. And in fact, this is possible by using the OpenCL 1.1 library. This library allows for standard computing programming which makes use of the integrated graphics units as background coprocessor number crunching units. Using this, the graphics performance can be transformed into number crunching performance, quadrupling and even more the standard computing performance of the CPU and the floating point unit on board of the embedded R-Series CPU. In fact, this is used quite often because if the requirement for graphics performance is fairly low or currently zero, then the whole graphics unit would be idle, and it is very nice to make use of the hardware available to solve number crunching issues, so that OpenCL has become quite popular in recent years. The version of OpenCL implemented on the AMD embedded R-Series is OpenCL 1.1. Inside the graphics unit, there is an accelerator for video encode and for decode, which allows for a resolution up to Full HD. At the same time, the module now also supports quad independent display support, and that means 4 displays, up to 4 displays, can be driven at the same time, each showing different and independent display content. This is a very powerful feature, and this is available for the first time on a ComExpress module. Next to that, the module has a combined LVDS and embedded DisplayPort interface, allowing to drive either conventional LVDS TFT panels or the more up-to-date embedded DisplayPort panels, which are now becoming popular as well. On this baseboard here, I'm running the new module, and currently it is running Windows 8. And you can see here the innovative desktop of this new operating system. I want to prove the graphics performance of this device, and I am showing now a full HD video that is decoded in real time and displayed in 1080p quality. As I said before, the module is capable of driving up to 4 individual displays at the same time. Each of these could be up to 1080p Full HD resolution, or smaller, of course. Apart from this, the module has got some more features which I would like to mention here at this time. First of all, there is micro SD card slot, which allows to insert micro SD cards, and software on these micro SD cards could be bootable, and the module can execute code that is stored on these micro SD cards. On the module there is also a TPM chip allowing hardware-based security, which can be made use of in application programs to bring software to the market which is safe and cannot be copied or tampered with. For the operation of Type 6 ComExpress modules using these standard ComExpress connectors, MSC is offering several types of test boards and application platforms. One is a large ATX size baseboard, which is called Type 6 EVA baseboard. Another one is a smaller one, which can be used as an aviation vehicle just to plug in a Type 6 module and operate it in the lab, for example. And some more baseboards Type 6 are in development, which will allow application systems to be built with quite compact sized baseboard like this mini ITX board, and these will be made available later this year. Samples of the C6C-A7 are available immediately, and volume production will start middle of the year 2013.